All right. Well, happy Friday, and we'll continue on learning about Python. And so now we're talking about lists in Python. Lists are very important, and um, and yeah. So we introduced lists. We introduced lists on Wednesday, and here we'll continue on. All right, so an important idea is that lists are what we say mutable, meaning that the object in memory can be changed within memory without creating, say, like a new thing. Okay, so in contrast this to R. All right, if you have like a vector in memory and then you modify it, okay, what R actually does is it creates a copy and it modifies the copy. Whereas in Python, the object itself, the object that exists in your computer's memory that you're interacting with and stuff, gets modified. I use kind of this term in memory a lot, and maybe I don't know if that's something that's like unfamiliar. So your computer has a few different things, right? So you have storage, okay, which is like your disk drive, and that's like that's where you store the programs and the operating system, and you download a picture or something. That all goes in your storage. But then when you are interacting with it, okay, there is other stuff called memory, and the computer holds the stuff in memory and allows you to kind of interact with it. It's very rare for you to interact directly with storage other than when you're like saving and opening a file, okay? But when you're kind of interacting with something, and it's almost always going to be done in memory, okay? Otherwise it takes it's much slower. Okay, so anyway, when we type something out, create this, and this object, this list exists in memory. and so fam, the name, points to this list, okay? Here, and I print it out, and it prints out this first line, okay? Then I say second equals fam. And so the name second points to the exact same object, okay? So it's kind of like having a nickname, right? So we have Joe, I don't know. Is Joe Bruin's full name Joseph Bruin? No. It sounds weird to say that. Okay, so we have Joe Bruin, and then we have I don't know, the UCLA mascot or whatever, right? And we're both talking about the same exact thing. Okay, so it's two names pointing to the same thing. So then if I refer to second, okay, index 0, and I say change it to sister, okay, it's going to replace Liz with sister, and I can print that out, and it prints out this list, okay, where that first item has been changed. Okay, fam is the exact same list, okay? Changing the list second has changed the list fam. It's the exact same list. So when I say print fam, it's the exact same list as second here, okay? Meanwhile, over here, we're going to create a copy. So fam, I'm going to create a brand new list, and I'm going to call fam, call it fam. Okay, so fam references this brand new list, print it out. Okay, and then here I'm creating a copy. I'm slicing out everything. That creates a copy. I could also do fam.copy. That will create a copy. Here I'm doing fam slice everything. Okay, and so now I have two lists. Okay, I have this list, and then I have second, which is another list with the exact same contents, but they're different things. One's a copy of the other. Here I'm going to modify the name Liz, replace it with sister, okay, in the second list, which is a copy. And so when I print out second, that's going to reflect the change. But then when I print out fam here, the original list is unchanged, okay? So that's what we see here, okay? This is the first list fam. This is the copy, and then I've modified the copy. this is we're printing out the original list there, okay? Here I can create another copy of FAM. So I'm going to create this. I'm going to replace index 1 from 1.75 to 1.65, okay? And so this will reflect that change, okay, to 1.65. Okay, I've copied FAM originally. FAM through all of this stuff has remained unchanged. Okay. If I take the FAM list and I create, and if I wrap it in list here, this will create basically a copy as well. Okay. So here, list 2 is a copy. This is not the preferred way of copying a list. It works, okay, but it's not the preferred way. You can just kind of take an existing list, say make a list. So this function list basically takes whatever you put inside of it and tries to make a list out of it. So like other uses of list is like you can take the string hello and say try to make it into a list, and what it's going to do is going to break out the letters HELLO and turn that into a list. Okay, you could take other things like, I don't know, you can have a tuple. So we'll call this TU is going to be a tuple 1, 2, 4. Okay, and then we could say make a list out of the tuple. Okay, and then it makes it a list. Whereas the tuple itself is still a tuple. Tuples are represented by curved braces. Okay, and lists use square braces. And we'll talk about tuples later because those are also important. But anyway, so you can create a list by taking an existing list and wrapping a list. And that will create a copy. Not the preferred way. If you want to make a copy, we recommend using either the slice notation, okay, or the dot copy for that. Just because things can get wonky, I guess. I mean, if it's just a list, this should work all the time. Okay. All right. You can also... Here I'm going to use list slicing in conjunction with assignment. And so if I want to change from 1 to 3, okay, so basically from here to here, I'm going to replace 1.73 with 1.8 and replace Emma with Jenny. And so FAM is going to be modified. So this is the originally FAM. I replaced 1.73 with 1.8. I replaced Emma with Jenny. Okay, so that's just examples of showing how the object in memory is being modified. Okay, we've seen list.copy already, allowing us to make copies. This creates what we call a shallow copy, and I'll get into that in just a moment. Another very kind of useful method for lists is the append method. Basically, you take an existing list, and then you tack something on. You append it. Okay, so here, I'm creating a brand new list. Okay, every time you see a square bracket to create a list, you are creating a brand new list. Okay, so I'm creating a brand new list. I'm calling it FAM. And then I'm going to do dot append, fam.append, and it's going to tack on me here. Okay, so one thing that's different about this, because you can append things to like a vector or a list in R, but you have to always kind of save that, right? Like if you have an existing list in R and then you add something to the end, you have to assign it back to a name. Oftentimes you assign it back to the original name, so it replaces the thing. But in Python, because it's mutable, when you do fam.append, it's just going to modify the list fam in memory directly. Okay, you don't have to say fam.append is equal to something. You don't have to assign it equal to anything. Okay, so here we could see me gets appended to the end of the list right there. Okay, you can also append things by doing plus. Okay, plus basically takes two lists or two iterables and then concatenates them together. So basically, I'm taking the list fam here, and then here I'm creating a brand new list. Okay, again, anytime you see the square brackets to create for a list, you're creating a brand new list. Okay, this is a brand new list that we haven't named. Okay, but I'm appending it. Okay, I'm saying take the existing list fam, take the list, this list containing 1.8, and connect them together. Okay, but this is just an operation. If I do this, here, let me just do this here. So if I do this, this is kind of like doing 4 plus 5, okay? And it's going to return the result, okay? Not 9, but it's going to be the list with the extra stuff, right? We see 1.8 gets tacked on at the end, okay? However, I didn't say set this equal to anything, okay? So this doesn't modify fam here. If I ask what is fam, it doesn't have the 1.8 here. So if you're using the plus operator, this doesn't modify the thing that you're adding to, right? It's kind of like here's something and here's something, you know, what do you get if you join them together? And it's saying if you join this list and this list together, you're going to get this, okay? But does that actually change this first list? It doesn't, okay? If you want to change it, you got to do something like this, fam plus 1.8, assign it back to fam, okay? And so I wrote this output needs to quote unquote be captured, right? So we have to save it and assign it back, right? And then, so now if I do that and then I say print out fam, then we could see it has been changed, okay? Fam.append, again, just kind of tacks things on, modifies it directly. So here, when you run fam.append, it doesn't look like anything happens, okay? But it definitely has, okay? And we can see it has changed, okay? If I were to run this again, if I go back and run it again, then it'll just kind of keep appending things to the existing list. So you got to be careful about doing stuff like that, okay? Here, append only allows you to add one object, okay? Only allows you to append one object. And so here, if I say I want to append this list of 4 things, it's going to tack this on as one object inside the list, okay? So what it's going to look like is now this is going to be contained as a list within a list in the last index position, okay? And because it's gotten so wide, it now prints it vertically. So sometimes as Python, as the output gets wider and wider, then it's going to just reformat the list into vertical style. But you can see it's still everything. This last part here just got appended as one item, okay, as a list within the list. Okay, so if we don't want that, okay, here I'm creating a brand new list, and then I'm creating another brand new list, and I'm going to say take fam, and then take these 2 things and concatenate the list, okay? And then now it contains everything. It has Liz, Emma, Mom, Dad, and then also Miles and Joe, right? So all of this stuff is here, okay? Does this modify the original thing, fam? It does not, okay? Because we're just adding this, okay? You can also do multiplication operators, right? And multiplication for iterables behave the same way in that it's kind of like concatenating the thing to itself. So now we have Liz, Emma, Mom, Dad, and then Liz, Emma, Mom, Dad again. Okay. So if you think about the multiplication operator applied to a string, it just takes the word hello and you do like hello times 4. It goes hello, 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 hello. And it's basically doing the same thing, except it's just doing a list, and it's taking the list and it's going to just append it to itself times. All right, let me give you your first view quiz answer today. Letter B. B as in bear. B as in bear. Okay, so we have, let me just talk about copies, and then Python also supports something called a deep copy, okay? And you might go, what's the difference between a copy and a deep copy? Okay. So for a lot of like, if A is a list like this and B is a list, a copy and deep copy are exactly the same. Okay. But you can have objects referenced inside other objects. So you can have a list containing other lists, okay? And you can reference those other lists by name. So here I'm creating a list A, and then I'm creating a list B, and then I'm creating a list C, which is a list of lists. It is a list containing object A and object B, and object A and object B themselves are lists, okay? So if I say, hey, what's C? It is now a list containing list A and a list containing list B, okay? Now, remember, all of these things are objects that exist somewhere in memory, okay? So inside Python's kind of whatever mind, you say, hey, what's C? And then Python says, oh, C is a list containing list A and list B. And then you say, well, what's list A? Oh, list A is this list containing A12. And what's list B? B is a list containing B34, okay? But Python knows C is a list containing list A and list B, okay? Now I'm going to create a copy of list C. This is we're gonna call this list D, okay? When you create a shallow copy, right? So we say, hey, what was C? C is a list containing list A and list B, all right? And then you say, okay, well, I want to make a copy of that, okay? D is also going to be a list containing list A and list B, okay? So a shallow copy copies this list, but it copies only the references. Contrast that to a deep copy, right? And so right now, these all look the same, okay? And then I could say, okay, well, you know what? I want to take list C. List C contains is a list containing list A and list B. And I could say E, make a deep copy, okay? So you have to import copy, and the function is copy.deepCopy. And what this is going to do is it is going to not only copy list C, but it's going to say, oh, list C contains a list A and a list B. I'm going to create new copies of those objects inside of list C. Okay, so maybe I can draw this out. Okay, so I have A, which is A12, and then B, B34. Okay, and then C is a list containing A and B. Okay, and so this points to here, and this points to there. Okay, D is going to be a copy of C. All right, so we're going to get A, and we're going to get B, and these are pointing to the same things. Okay, they're pointing to the exact same objects. Okay, whereas E is going to look at this and say, we're gonna get like basically new A, which is going to be a list containing A12, and then we're going to get new B. These actually don't have names. Okay, they are unnamed. They just have but we get copies of these things. So these are different things. But right now, when we say, hey, what does E look like? They all kind of look the same. They all look like A12, B34, A12, B34. Okay. So what's going to happen if I say append X to C? Okay, and I print out what is C. C is now going to have X attached to it. Okay. And so here I've appended so that's what we have. So we have list A, list B, and X. Okay. D is a copy. We didn't append X to D. So D is A12, B34, okay? And E is over here, and we say, hey, what's inside E? It also looks like A12, B34, okay? All right, now what I'm gonna do here is I'm going to append Z to list A. Okay, so I'm gonna change this. Right, and we're gonna tack on Z here. Okay. So if I say, hey, what is A? A now has A, 1, 2, and Z. Okay. So now if I say, hey, what is C? And remember, this A is pointing to this, and this B is pointing to this. Okay, and if I say, what's that? C now has A, 1, 2, Z. B has B, 3, 4. And then it has X. Okay. What is D? D is pointing to this list. So D is going to have A, 1, 2, Z. B will be B, 3, 4. Okay. And we have that. Okay. But what about E? E is a deep copy. And so this A doesn't point to that, but it points to its own internal thing over here. Okay. So if we ask what's inside E, it's going to still be A12 and B34. Okay. So does that kind of make sense? The difference between D being a copy of C and E is a deep copy of C. All right. Okay. And so, same kind of thing we can ask, what about C1, D1, and E1? They all they all have the value B34. Okay. There's a way to see if two things are the same exact object, okay? And that is the is operator, okay? Is C index 1, is this the thing inside C index 1, is that the same thing as D index 1? That answer is true because this is pointing to this object and this thing is pointing to the exact same object, okay? If you say, what about D index 1, which is this list B, and E index 1, which is this list B over here, if you ask is, it's going to come back false. It's going to say, oh no, this thing is this object over here, and then E index 1 is this object down over here. Okay, so that's a different thing. So that says those are not the same. However, is not the same thing as equal. Okay, this is the equal thing here is, are they equivalent? Okay. So if you say, is the object at D1, is that equivalent to the object at E1? That comes back as true. Okay. So is a matter of identity. Okay. Are we talking about the same person, or are we talking about the same object? Okay. Or are we talking about things that are equal, right? Like I could have my copy of a book, right? We buy the same book, okay? Is my copy the same as your copy? No, okay? Are books equivalent? Yes, all right. If I'm sharing my book, right, like with my family, and we say, oh, do you have your copy of whatever book we're talking about? Okay, we like my family members might be referring to the exact same object because I only have one of this book inside my house, right? So if I talk about my book and, let's say my child talks about the book, we're talking about the exact same object, right? But if you're talking about your book, okay, your object is different from my object, even if they're equivalent. And that's the difference between the is and the equal sign here, the equality check. Okay, so that's the difference between copies and deep copies. All right, we have insert. Insert is kind of like append, except you are putting it at index position I. Okay, and then so if you do insert 0, that's going to put it at the front of the list, and then if you insert it at the end, that's equivalent to appending it. And then you also have extend. And this is kind of like append, except you can give it an iterable, and it will kind of just extend the list here. Okay. So here I've got this, I'm creating a brand new list here, okay? And then I'm gonna say insert Joe at index position 4. And so kind of think of it as the fourth comma. So 1, 2, 3, 4. The fourth comma, it's gonna insert between 1.68 and mom there, okay? And that's where it ends up going, okay? If you try to insert an iterable here, it just inserts the entire thing as one object. So this is going to insert a list inside the list at index position 4. Okay, so that's what we end up getting there. If you wanted to put in multiple things there, okay, it doesn't let you do that. Okay, it says I was expecting 2 arguments because its insert is the index position and 1 object. And it says you gave me 3 things, right? You gave me 2 objects to insert, and so I don't like that. Okay. You can use extend, but that always puts it on at the end. Okay. And so we have that, right? And I think one of your homework problems is I gave you this kind of thing of like, what if you wanted to insert multiple things as an iterable into a certain position? And there's multiple ways to solve this. But one thing you can do is you can use list assignment and slicing, okay? So what slicing will do, along with assignment, is it basically takes whatever slice you have and it replaces it with whatever you're putting it in there, okay? And in this case, if I slice 4 to 4, I'm basically not replacing anything, okay? But I'm gonna just kind of put assign Joe, 2.0 into index position 4 here, right? And so you can see those things get inserted in there, right? So this is kind of a way around this limitation of trying to insert multiple things into stuff, is assignment along with slicing. Okay. All right, so we are going to continue on here. Okay, so we can remove items from the list. Okay, if it can't find it, it's going to give us an error. All right, so here I've got the list. I can say remove Liz, and it does that. Okay. Here I'm creating a brand new list where I have 1.71 appear multiple times. And if you do remove, it only removes the first match. It reads left to right. And when it encounters the first match, it removes the first one. Okay, it doesn't remove all instances of it. Okay, there's pop, and then there's clear. Okay, pop is going to remove the item at the given position in the list, and it returns it, okay? And then if you don't specify an index, it will pop the last item. So here, I'm gonna say, here's my list. J is, let's pop, it's gonna take the last item, 1.89, it's gonna assign it to J. So if I say, hey, print J, it's gonna print out 1.89. If I say print the list, it's gonna have everything up to dad. Okay, and that's what we have, right? You can do pop 0, and it's going to pop index position 0. So here I'm creating a brand new list. Pop 0, we're going to pop, Liz is going to go into J, and then the list will be everything without this, okay? So, there's things kind of known as stacks and queues, okay? If you use pop without an index, it behaves as a stack, and the idea there is like if you have a stack of paper, the last piece of paper that got added to the stack is going to be the first piece of paper that you pull off of the stack, okay? Versus a queue is kind of like the first person in line in the queue is going to be, and then multiple people keep lining up, all right? The first person that's going to get treated or served is going to be the first person in the queue, okay? All right, and then fam.clear just takes whatever existing list is and then gets rid of everything inside, okay? And you'd be like, well, what's the point of that? Why don't I just create an empty list, okay? Again, everything the object, this is an object in memory, right? So if I just, like, later on, if I just say A equals, if I just do this, A equals this, all right? What we're doing here is I'm getting rid of this name A. So this is now like unnamed, like we don't have a name referencing it, but internally in Python, there is like there's basically an ID that references this, okay? And so the A here still references this same object in memory. It doesn't, like, there's no magic with the names here. So this A doesn't suddenly now know to point over here. We've just created a brand new object in memory that is not associated with this. It just happens to have the name A here. Python recognizes that, oh, the name A points to this thing. This used to be called A, so I don't know what to call it now. I don't have a way to directly reference it, but it's internally, there's still like a memory address location. There's an ID number behind it. And so Python still internally uses those IDs to reference the object within memory. Okay. So if you wanted to clear this thing, you would have to use the list name.clear. All right. So if I did a.clear and this was still called A, it would clear it out. So like, for example, okay, so right now A is this, and if I say, you know, what's C, if I do that, I can do that, and if I do a.clear, and then I say, what is C, okay, now we see the list A is empty, okay? But then I can say, hey, what's list B? B is B34, and then if I do something like B is equal to an empty list here, this creates a brand new list that's empty called list B, okay? But it's not this thing, okay? So if I still ask what's C, C still has this, okay? I don't have a way to kind of reference this, all right? If I want to, I can still kind of get at it by doing like C index position 1, and I can do something like append X to that. And then C will now have that, right? So I can still kind of reference this. I just can't reference it by name unless I call it like, so I can kind of pull at it, right? C index position 1, I can give it a name BB now, right? And then so now this thing, now I can reference this by name, okay? It's kind of a lot, but it's just kind of like the idea of like all of these things exist in memory, and anytime you use a square bracket, you're just creating a brand new list, okay? And there's no magic with the names. It's just like, okay, we're gonna just call it this thing and that thing. Okay, dot index is gonna tell you like where's the index of the thing, and again, it just reads left to right. So if you do dot index, it's going to say, hey, Emma is in index position 2, okay? If you give it a number that it can't find, it's going to give you an error. If I say, hey, give me the index of value 3, well, there's no value 3 inside this list, okay? So we get an error, okay? If you have the same thing appear multiple times, it just gives you, letters.count is going to go through and count how many times the thing appears. So A appears 3 times. So that's no surprise there. Here's a list of lists. And if I say, hey, look for Emma in here, okay, it's just looking at the top level list. So it's going to say, I don't find the string Emma anywhere inside the list, okay? But if you say, do you find a list containing Emma 1.68? Then the answer to that is yes, okay? You can take a list and you can sort it. And reverse it will take the list and just reverse the order of things. All right, so if here's my existing list fam, I can reverse it. Okay, again, anytime you call some of these things, it doesn't look like anything has happened, but it definitely has, okay? So fam is now in reverse order, okay? If you call fam.sort, it's going to say, I don't know how to sort this because it's got strings and floats, so it doesn't know how to sort that. But you can take, a list of numbers, and you can mix integers and floats, and it can sort that. That's no problem, okay? So here I've got a list of numeric values, some integers, some floats, and it sorts them, and it preserves the numeric data type. So if it used to be an integer, it remains an integer. If it used to be a float, it remains a float. Okay. You can sort them in reverse order. And over here, so this is a brand new list, and so dot sort changes the list in place. Okay. Sorted gives you a sorted copy of the list, okay? But the original list is unchanged, okay? So the original list, unaffected. This is a sorted copy. Okay. Let me give you your second answer. Second answer is C. C as in cat. C as in cat. Okay. All right, let's talk about strings, okay? With strings are sequence, they're iterables, okay? So I've got fruit equals bananas, and if you do index position 0, that's going to give you the first letter, B. If you give, say, index position 1, that's going to be the letter A. This is a lot like referencing, kind of like the subsetting operators for lists work the same way. It's just, it treats each character as its own element. So -1 will be the last letter, so that's going to be S. And then if you give it a float, it's going to say, I can't deal with floats as far as indexes go, okay? So, but this is exactly the same way that it has, right? Length will tell you the length of a string, also tells you the length of a list, okay? So length also works on the list. So with fam, there were 8 items in the list, okay? And the length of fam2 is a list of 4 lists, right? Okay, so here I think I got the alphabet, and you can slice, right? So what is 4 through 9 going to slice out? Okay, 1, 2, 3, 4. It's going to start off at E, and then 5, 6, 7, 8, 9. E through I. Okay. -6 colon. That will give us the last 6 letters of the alphabet. So I think U, V, W, X, Y, Z. Okay. And then, you can slice a string, and then you can iterate over it using a for loop or whatever. Okay, so I say for X and this, and so this is going to just take the first 5 letters of the alphabet and tack on a exclamation point, okay? And again, this is kind of like, if you think about the way Python treats a list, the plus operator for how it treats a list is very similar to how it treats the plus operator for a string, okay? It just says, oh, here's a string, here's another string, we'll tack them together, okay? Whereas, when you have a list, it's like, here's a list, we'll tack them together. And so basically, I'm just saying, take the string, it's going to be the letter A, tack on the exclamation point, okay? Take the string, which is the letter B, tack on an exclamation point, okay? In contrast to lists, strings are immutable, okay? If you try to modify something, okay? So like, remember, S is the alphabet. And if I say, hey, you know what? Take the thing in index position 0, which is the letter A right now, and replace it with B, okay? Python's going to say, I can't do that, right? So strings, it treats strings as immutable. It's a strings object, do not support item assignment, okay? So with a list, you can say, hey, take this thing and change that. Strings, you can't do that, okay? If you wanted to do something like that, you can say, take the string B and then take all of the letters from B through Z, okay? And basically we're replacing the first letter there, okay? But this creates a brand new string. We're not modifying the existing string with A through Z. We're just creating a brand new string. Okay, we have some methods that are specific to strings. So we can like make them uppercase, we can capitalize, title case, lowercase. Again, all of these things, none because strings are immutable, none of them actually modify the string itself. It just returns a new string after doing whatever operation here is, okay? It always returns a new string. Okay, so uppercase just makes everything uppercase. Capitalized takes the first character and capitalizes it. Everything else will be lowercase. Title case does everything that is every first character after a space or white space becomes capital, okay? It doesn't know like the English language conventions where, what is it, conjunctions and prepositions are not capitalized in titles of books and movies and stuff. So it capitalizes and for and things like that. But in general, you know, that's not how it goes, okay? And then lowercase is lowercase. Again, the original string is unmodified, okay? How many times does a letter appear in a string, okay? So here's a loop that will do this, and you can say, hey, I want you to go through each letter inside this string and see if the letter is equal to E, then add 1 to the count and print out the count at the end, okay? And then so it goes through and says, oh, I've detected the lowercase e, it's case sensitive, the lowercase e appears 5 times, once in other, twice in technologies, and twice in science. 5 times, okay? You can also just do name.count, okay? Name.count looks for this. Again, it, much like how the list works, right? So a list contains a whole bunch of things, and you can say, count how many times this item or object appears in the list. Okay, you can do the same kind of thing here, right? You can do .index. Index will give you the first instance of the capital letter A, right? Which is index position 2. Ends with, this is going to be true or false. Ends with K, that's false. Ends with an E, that's true. Starts with S, lowercase s. Does it start with a lowercase s? It does not. That's false, okay? So these are just kind of, and it's just the name of whatever string it is, okay? So here I've been doing name. Name is this thing here, but you know, you could also, okay, you can just take the string directly and then do a dot and access the, what do you call it, string methods there, okay? So does hello end with an O? Yes, hello ends with O, that's true. It seems silly to do it that way, but it's possible, okay? All right, if you want to create a string with multiple lines, you can open and close with triple quotes, okay? So name2 is this, Miles Chen with leading spaces and trailing spaces, okay? There's .strip. Strip removes leading and trailing white space, okay? Doesn't remove internal white space, okay? So we have that, right? But again, this doesn't modify strings. This returns a brand new string that has been stripped, but the original string is still unchanged, and the raw form is, it has new line characters, /n, /n, \n, \n. All right. String split takes a thing and then it splits it at the white space, okay? All right, so here it pulls out and it basically extracts out words kind of thing, okay? Things that are separated by spaces. You can, by default, string splits on space, but you can also give it a character. So here I have a numeric string, 2 comma 3 comma 4 comma 7 comma 8, I can say split on the commas. Okay. Numeric string dot split looks for spaces and it doesn't split anything. So we have basically I get a list with one string in it. When I do this split on the commas, I get a list with 2, 3, 4, 7, and 8. Okay. But this is a list of strings. It's the string 2, the string 3, the string 4, the string 7, the string 8. If I say like, hey, I want to take this thing and then I want to like do the sum, okay? Because if I have a list like this, I think I can just do sum. No, I can't. Can I do this? I forget what I'm allowed to do. Okay, so I'm allowed to do that. But if I try to do something like this, with this, it's going to say, you can't do that because all of these things are strings, right? So if I try to, basically I'm trying to sum this, okay, and it says, you can't do that, okay? So we can do what's called a list comprehension, all right? And then I can say, hey, take each of these things that you return and make it an integer here, right? So now this is a list of integers, and then I can run the sum on that. Okay. I'll cover list comprehensions, I don't know, probably at the very end of class, but it's kind of just like running a for loop, where I can say, hey, take numeric string dot split, okay, and it's going to basically give us back this string, that list up there. For each element in there, turn it into an integer on X, and then append it to our empty list L, and then what's the result of that L list there, okay? We have a couple other true-false things. So we have is alpha, okay? Is alpha just means, is it just alphabet characters, A through Z, capital and lowercase, okay? So because name has spaces and numbers, it's not alphabet characters only, okay? But A, B, B, A, A, Z, that is alphabet characters only, okay? This, because it has the digit 4, is not alpha, okay? I think is there alpha num? There's a couple of things. No. Is alpha, it's kind of a the word alpha now has weird connotations to it now, so is it alpha? This is false. Okay. All right, you can have a long string. So here's some lyrics. Okay, you can make everything uppercase. You can split. Split will separate at the spaces. Okay. Split lines separates at new line characters. Okay, so now I'll have a list where each line is one line from the thing. I can go through and I can count how many times the letter E appears or something. Okay, we might want to say like, okay, I want to look for the letter T or something like this. Okay, so here is a function that I wrote. I'm going to just skip over it because it's not, because there's already a function in Python called find. Okay, dot find will find the first instance of the character T. Okay. And you'll go like, oh, I thought we already have a function called index, dot index, okay? And dot index also gives you the index of the first position of the instance T. And you go, okay, so what's the difference? There is a difference, okay? Dot find, if it can't find it, it returns a -1, okay? Dot index, if it can't find it, returns it, stops running, okay? That's an error. So there is an difference. And so dot index, you use if you want to be sure that something exists in there, okay? And then basically, if it can't find it, it halts, right? Like we got a person missing, we got to stop, okay? Okay. Dot find is kind of like, oh, did the person sign up? Do you find them on the list? No, okay, but that's not like a missing person situation. We don't have to suddenly halt everything and then fix the issue, okay? Okay, in is check. You can check to see if like substrings exist. So is A in bananas? What about nan? What about bad? So that nan is a substring in there. Bad is not. Okay. You have greater than and less than comparisons for strings, and this is like is one before the other in the alphabet, and so that's this and this. I think I've already gone through. So all of the comparisons as far as characters go is based on the ASCII chart, and you can say, well, what is the order in which these things go? And it didn't like that I have a backslash in there. But basically, the order of the characters are based on ASCII chart, and that's what we have there. Okay, last answer today is the letter A. A as in apple. Okay, and we'll end there. Have a great weekend, you guys, and we'll see you next week.